Okay, lesson 88, solving quadratic equations by factoring. I'm going to forget to do this lesson because I was thinking I didn't need to do it until tomorrow, but you have your test tomorrow, so keep that in mind. So far, we've only solved linear equations. Linear equations would look something like these kind that we've done. 3x plus 4 equals 12, something like that. This is called a linear equation. The highest exponent in the linear equation is always 1. When you graph it, you're going to get a straight line. This is a linear equation. Linear equation. And the highest exponent is 1, and you're going to get one solution. So if we solve this, we would subtract 4 from both sides and divide by 3, and we would solve it. We're going to move into these things called quadratic equations. And there's a standard form for a quadratic equation. And the standard form is ax squared plus bx plus c equals 0. And this is called our standard form of a quadratic equation. The highest exponent in a quadratic equation is 2. If you were to graph it, it wouldn't look like a straight line anymore. It would be a parabola. It would either be an upward-facing parabola or a downward-facing parabola. We'll graph these in Algebra 2. And typically with a quadratic equation, but not always, we can get two solutions, depending on when this graph crosses the x-axis. So if we had an axis here, the solutions would be right here and right here. That's where it crosses the x-axis. However, if it crossed the x-axis, if it didn't cross the x-axis at all, there'd be no solution. And sometimes just one point hits the x-axis, and this would be no solutions, and this would be one solution. But we'll get into all that in Algebra 2. Today we're just going to work on how to solve these things by factoring, not by graphing. So we'll get into how all this works in Algebra 2. So let's just try a couple examples of how to do these. Here we go. It's going to say solve, and here's our quadratic equation. The first one is in standard form. You see how it's in the standard form? We have our x squared term first, our x squared term second, and our constant term third. You have to, in order to solve these, you need to set it equal to 0. This set equal to 0 means that everything is on one side, 0 is on the other side. And the exponents have to go in descending order. We have x squared, x to the first, and this should really be x to the 0. Remember, x to the 0 is just 1. So our exponents are going in descending order. After you put it in standard form, today we're working on how to solve them by factoring. It's our method of choice for today. So we're going to factor, because we learned how to factor so well earlier. We say what times what gives me x squared? Well, that would be x times x. And we would say what times what equals 3. And when we add them, we get 4. Well, that would be 3 and 1. Signs are going to be the same, and they're both going to be plus. So we factored them. And by factoring them, what we're saying is this factor times this factor has to equal 0. Well, in order for two things to multiply together to give you 0, one or both of these factors have to be 0. And I'm not going to get too much into the details of how this works this year. We'll get into that more next year. But what we want to do is we want to find out what would make this factor 0 and what would make this factor 0. And we do that by setting them equal to 0. So we say x plus 3 equals 0 and x plus 1 equals 0. So what we're really doing is finding out what x has to be in order for the factor to equal 0. We could just look up here and say, okay, if x is minus 3, this one's going to be 0. And if x is minus 1, this one's going to be 0. And that works temporarily when the problems are so easily, but you need to understand what we're doing. So I want you to set each of the factors equal to 0, and then we're going to solve each of these little mini equations by subtracting 3 from both sides. We will get x equals minus 3. And over here we will get x, we subtracted 1 from both sides. We get x equals minus 1. So these are the two solutions. Remember I said often in quadratic equations we're going to get two solutions. We have an exponent of 2, and it tells us we're going to have two solutions. And if I would put minus 3 up here, I would get 9 minus 12 plus 3, and that does equal 0. And if I put minus 1 up here, it would also equal 0. That one was already in standard form. Let's try a couple problems that aren't in standard form. Here's our first one. 5x minus 14 equals minus x squared. Big hint, you want to get your x squared term, you want to make sure that this is positive. So I'm going to take everything, which is only the x squared, negative x squared term, to this side so that it's positive. So we're going to get x squared. I'm really adding x squared to both sides, right? I'm adding x squared to both sides. That's why it's positive over here and gone over here. Plus 5x minus 14 equals 0. Since I added x squared to this side and I added x squared to this side. Now it's in standard form. It's in our ax squared plus bx plus c equals 0 form. Now we can try factoring it. Later we're going to get to the point where we can't factor it. It doesn't work. And we'll use other methods to solve this. So we say what times what gives me x squared? Well, that'd be x times x. What times what gives me 14, but when I subtract them, I get 5. That's easy. 7 minus 2 gives me 5. And there we go. We have our two factors. One or both of these have to equal 0. So we have to figure out what will make them 0. X plus 7 equals 0, or x minus 2 has to equal 0. And when we subtract 7 from both sides, we get x equals minus 7, and we get x equals 2. So these are our two solutions. Remember, two solutions, exponent 2. Let's review. Put it in standard form, set it equal to 0, factor, set each factor equal to 0, and solve, and you'll get your solution. Let's try another one. I don't want this video to last all day. X squared equals 9. Alright, we're missing our x term, but we can proceed. It's still quadratic because quadratic means it has an exponent of 2. The highest exponent is 2. So I'm still going to set it equal to 0. I'm going to keep this x squared term positive. So I'm going to subtract 9 from both sides. So our 9 is subtracted from here, so we have 0, and it's subtracted from here. Now this is the difference of two squares. This might catch you off guard. So remember, a difference of two squares, they're perfect squares. We can still factor them the same way. X and x. There's no middle term because if we have a minus 3 and a plus 3, if we check our outer and our inner, we don't have a middle term anymore. Now we just set each of these equal to 0. X minus 3 equals 0. X plus 3 equals 0. And we get two solutions. X equals either 3 or x equals minus 3. They're both solutions. If we square either of them, we're going to get 9. So it works. Let's try to do one more. Okay. Here we go. Let's see. Which one should I pick? Let's do the hardest one I have. Minus 25. Whoops, which one's 4? Minus 25 equals minus 4x squared. So again, we need to set it equal to 0. We're going to bring this one over to make this positive. So we're going to get 4x squared. We're going to add 4x squared to both sides. Minus 25 equals 0. Difference of two squares, perfect square. Because 2x times 2x gives me 4x squared, and 5 times 5 gives me 25. And it's a difference of two squares. So we make two sets of parentheses. And we get 2x minus 5 and 2x plus 5. Remember, difference of two squares, the signs are going to be different. So when we do our outer, we get 10x minus 10x. We have no middle term. So we get 2x. We set each of these equal to 0. We're going to add 5 to both sides on this one, and we're going to get 2x equals 5, and divide by 2, so we get x equals 5 halves. Yes, you can have fractions, unfortunately. Subtract 5 from both sides on this one, and we get 2x equals minus 5, and divide both sides by 2, we get x equals minus 5 over 2. So feel free to rewatch this video when you get to these problems, and we'll of course do a reason class whatever you don't get. So that's it for lesson 88.